Okay, before we jump into Substance Designer, I wanted to bring up a couple important points. One, obviously, you want to make sure that you save your material ID document uh, so you can use it in the next program. Also, the normal map we created for, in nDo was, let me zoom out here. It was created using the Y up channel, essentially. It's the standard OpenGL format, and it's the one that nDo uses for viewing the normals in the forgive me, in the application. And let me give you an example here. I'm going to load this current document as normal here, and then maybe I'll use a standard cube or a plane to view them instead of my mesh. Okay, so the problem here is if we're going to go to a game engine, and most game engines, at least Unreal Engine and CryEngine, that use DirectX will use the DirectX format normal map, which has the Y channel reversed, and you can change the Y channel in a couple ways. In Substance Designer, we're going to use them as a DirectX normal map just to keep things simple. So if we had this Photoshop document compressed all in one layer, like maybe just a TIFF file or a PSD file, all we'd have to do is go to these channels here, go to the green channel, and reverse it. But I have all these layers created, and I'm not going to compress this document. I'm just going to leave this as a Photoshop document that I can use in Substance Designer. So nDo provides an easy way to flip the normal maps. So when you start the program back up here, give it a moment to engage. There we go. You have the options in your preferences to reverse the Y channel. The options here, this drop down arrow, preferences, flip normal channels, flip Y. There we go. So that's been flipped, and it appears in the document. Oops. Forgive me, I have my OpenGL turned off, so my click, zoom, and drag doesn't work as I expect. Looking at my RGB channels, it appears in the document that my normals have flipped. So if I refresh nDo here, you'll see what I mean. When I go to my normal map, refresh, see these pop out? Normally this portion drops in to the mesh, but now it's popped out. It won't look like that when you're viewing the normal map as a DirectX format. But again, nDo uses the OpenGL version. So when I create the normal map and I'm using nDo, I normally have a Y channel positive, but I flipped the channel here in before I export it, essentially. So now I'm going to save the document, close this, save the Photoshop document, and now we can go to Substance Designer, and we can use these maps we've created, bake some new ones, and then work on the layered material workflow. Okay, when you open Substance Designer 4, which is what I'm using, it's their latest version, you have the option to select some recently used graphs that you'd created, as well as creating new ones or opening a document that doesn't necessarily, it wasn't a recent one that you created. This will be a very quick primer. There's a lot of videos on the internet on how to use the basics of Substance Designer, but I will try to give you a quick overview now, and in the next video we'll go into doing something, plugging this asset into a pipeline that you've already created. For example, I've created many assets before I made this box object, which means I've already created a substance graph with all the materials and the wear, the scratches, the dirt, the dust, the grime, the grease, and so I can take the asset we just created, plug it in here, bake some new maps, and use those maps to drive some effects in Substance Designer. And Substance will automatically generate unique materials and wear and tear for this asset based on the maps I provide. And I don't have to recreate or repaint anything from scratch. I can use what I created for other assets, and they'll be unique because a lot of it's done procedurally, and I'll explain that in a little more detail. But right now, I'll just create a new substance and show you what it looks like to do that. So when you create a new substance, you have templates to choose from. If you're doing something with Unreal Engine, Unity 5, I suppose, and certainly CryEngine, the latest version, you want to use the physically based format, right? For reasons that I want to explain now, but use it. And if you're using Unreal Engine 4, we're going to use the metallic roughness physically based model, which is the Disney model that they're using. It's got a metallic map and a roughness map, as opposed to the other physically based model that's used by CryEngine, a lot of other 3D applications, and Unity 5, which uses the specular and gloss model. So the one you choose here is important. You do have to know what the final application you're developing for, so you can use the correct model. Now, if you start with a metallic and roughness model, Substance Designer does provide some pretty great nodes where you can convert metallic roughness into specular and gloss maps if you need to, for some reason, transfer these assets to another engine or renderer that does not use a metallic input. Okay. So for the size mode, I'm going to make this relative to parent. What that means is size mode is going to be the resolution of the actual texture, and if I choose, I can choose a default size, or I can use, say I want to do 1024 by 1024. Or if you choose relative to parent, you won't have the option to choose the size here. You can dynamically change the size of your texture within Substance Designer. And if you plug your substance directly into Unreal Engine 4 or Unity, you can dynamically change the texture resolution in the game as well. Okay. Right now, I'll just keep it relative to parent so I can tweak that here, even though I do know I want it to be a 1024 by 1024 document. If things tend to run slow, I can decrease the texture size for a little bit. Right? So it makes sense. Diffuse, normal, roughness, and metallic are what I'm going to work with. You can also add another output here, like ambient occlusion if you want, because Unreal Engine accepts that. I didn't use those too much in Unreal Engine because I found that it blacked out my models a little bit too much. The ambient occlusion came on a little strong, and rather than try to modulate that, I just let Light Mask kind of calculate some of the diffuse lighting and some of the occlusion. A lot of the textures I was creating used ambient occlusion to collect dirt in certain areas, so I still got a similar effect. Okay, so I'm going to hit OK. And Substance Designer will automatically create the graph for you. Navigation is pretty easy. Middle mouse button to pan, left click to make selections, right click to give you menu options. Down here you have your material window. I'm going to reset my view here and make sure my material is set to the physically based shader, which in this case it's the metallic and roughness model. If you're doing a different texture types, you can change your shader to physically based, specular, and gloss. And you can hold shift to change the lighting in this scene if you want, which you don't really see very much now. If you want to change the environment, you can go to Scene and Edit, and down here you have the option to change the exposure of your environment, the brightness, because it uses high dynamic range images to light the scene. Because it's a physically accurate renderer that you have here to get a very good picture of what your final images are going to look like in game. And then you can also rotate your scene as well if you want to change where the primary lighting is coming from. Okay, and you don't have to use the default cube. You can import any asset you want, and you can also turn off the background. And I do that quite often by selecting this true and false option here, just so I can focus on my assets and not be distracted by the grass and the sky in the background. Navigating in the viewport is pretty standard. It's a Maya style viewport navigation. Hold Alt, left click to orbit, right click to zoom, and Alt middle click to pan. Okay, so first things first, you'll notice these nodes here. 256 by 256 is the final output resolution. You can change that here by double clicking on your graph background, and you can change the final size here. I changed it, I knocked it up to 1024 by 1024. That's going to be our final output. And from here, you import your assets and you plug in your mesh items. I'll show you what that looks like here from a blank graph, though we're going to do that again in our final graph. So you can right click on these unsaved packages and choose link 3D mesh, and I'm going to go to my recent places folder and choose my mesh from the option, and a new folder was created under here called resources, and beneath that box haul, which is our mesh item. If I double click on it, it'll automatically appear in the viewport, and I can zoom in, or I can tell the view to reset, but it doesn't do anything. I have to zoom in a little bit here on the item, and what I'm going to do is turn off the environment again, and you rotate it a little bit to make sure I get a reflection I want. And I may export the asset out of my 3D application again, because sometimes if you export the asset when it's too small, right, it's not scaled properly, your camera controls can be a little bit wonky. Yeah, I'm going to do that again. Oh, here we go. I think it zoomed in properly for me that time. Scratch that. Okay, now when it comes to materials, it's very simple to plug in a material in Substance Designer. They've got a great layered material workflow in Substance Designer 4. So you can do a lot of your material layering here, and you don't have to do that with nodes in your 3D game application, right? So you layer materials in this document, you export your texture maps, and plug those into your standard diffuse, specular, gloss, roughness, metalness, and normal maps, whichever model you're using. Okay, so I can create a standard material here, if I would like, by right-clicking on the graph, choosing a new, say, uniform color, and I can take this uniform color and plug it directly into my diffuse color here. Now you won't see it automatically update in the 3D graph because I haven't told it that I want it to do that yet, but I can right-click on the graph background and tell Substance Designer that I want to view the outputs in 3D view. And by outputs, it means these objects here. These are your final outputs in the document. Your diffuse, normal, roughness, metallic, and you can add as many of those as you want by right-clicking and adding a new output node. If you want a different texture type, it supports any kind that you would really need. Okay, so if I plug my diffuse color directly, my constant color directly into my diffuse, I can change it to any color I want, and dynamically it'll change in the viewport. Okay, and if I'm using a normal map, I want to plug in a true normal map into that field, and that's the one that we created in nDo. The roughness map it really just has to be a grayscale color, so you can add a new color node, or you can select this one and use Control Shift D to duplicate the node without linking it to the previous one. Double click on this node to bring up the properties over here, and you can select grayscale, because this does not have to be a 3-channel like an RGB image. It just has to be a single grayscale 8-bit image that I can plug directly into roughness. Control Shift D to duplicate it again, and I'm going to plug this one into metallic. Now metallic, for the most part, is really just an on and off option when you're choosing materials. Okay. So in this model here, because this is a metal, I want it to be on. I'm going to turn it all the way to white, and you'll see the reflection values change. The sharpness of the reflections and the specular highlights is based on the gloss color. So you can dynamically change roughness to make the item rougher or not rough. So if I move it all the way to black, you'll see that you have a nearly mirror-like reflection, and it's a strange color because it's green. So let me change this back to maybe a white. So you have kind of a chrome look to it. And as you change the roughness value, if you select a node once, the properties will come up in this window here. If you double click a node, the contents will appear in your 2D browser here, and it doesn't look like much now because these are solid colors, but it'll make more sense later when you're dealing with layered materials and normal maps. So you can change your roughness values dynamically here in this graph, and you'll see your roughness change in the 3D viewport as well as here. Okay, that's a standard workflow, and again, we're missing our normal map. You can create a base normal map here by using a color node and using, let's see, I think it's 128 by 128 by 255 is a flat normal color. So it's half the value of R, half the value of G, and the full range of blue will give you a solid normal color with no normal change in normal information. Now the great thing about Substance Designer right now, if we wanted to skip that entire process we did with nDo and just use dynamic nodes here to create normal information, we could do that. We can draw all the normal information that we had in nDo in Substance Designer. It takes a little bit longer, but it does give you more freedom. You can have it all procedurally based if you wanted to, or you can paint it using vector graphics, kind of like we did in nDo. I won't go into that process now. I did it a little bit before, and there are some advantages with doing it that way. Primarily, it's keeping you within one application, and if you enjoy the node-based or compositing with textures, then by all means you can stay within Substance Designer. Okay, now the real benefit of using a layered material workflow in Substance Designer is if you have pre-made materials. So right now we created one. Say you can name this whatever you wanted. We want to call this a steel color. Okay, so we have this entire graph, and the whole purpose of this graph is to give us a shiny, white colored, relatively low roughness metal object, right? So we could right now, if we wanted to, this new graph, we could rename it to steel, and we could save that. I'll name it steel example. Control S to save, and we can save that to our material folder. I've created a custom materials folder here because it's. Well, let me just save this as steel example. It's important. If you create a base material, you can create one without any dirt, without any grime. It's a material that looks perfect as if it just came out of the factory. It's a great way to kind of drag and drop materials into graphs, and by that I'll show you what I mean. Let me create a master graph here. New graph. We'll use the same metallic roughness model, and we will do a different, let's see, 1024 by 1024. Okay, again, now we're back. We have no information on this master graph, but what I want to do is use this this master graph to composite or layer all of the materials that I made. So for example, we just have this steel example that we made. We can drag that into the scene, and you can see this green dot right here? That's a what that is one output node for an entire material. And what I mean by that is if you hit the number 1 on your keyboard, you'll see that what you really have behind that green dot is a diffuse, normal, roughness, and metallic map. But instead of connecting each one of these nodes individually, when you hit the number 3 key on your keyboard, you can drag the entire material connection over to your maps, and it'll connect them automatically. Right? So no big deal, right? I mean, that's essentially what we had in the previous example. But where this really shines is if I disconnect these, I can layer another material directly on top of it. So let me take a material that I've already made and use maybe a dirt example. Okay, it's the same example. It's just a node that I had created for another example. It's kind of heavy though, so let me delete that. I'll just use something that's a little bit quicker to read. Maybe an earth one, right? It's a pretty fast node. Okay. So I have two materials here, and you'll see that this material actually is 4096 by 4096, and that is a good point to mention within Substance Designer. Is if you notice when you double click on this background, like I showed you before, you can dynamically change your texture resolution. And 2 and parent by 4 doesn't make much sense, right? When you want to work in terms of 256 or 512 or 1024 or 2048. What you have to do if you want to know the final texture resolution of your document is you look at your output nodes here. So 1024 by 1024 is our final texture output. All right, so I can change this up again, and I can make it 2048 by 2048, or I can drop it back. Now when I created this example steel node, you notice over here when we open it up that it's 1024 by 1024. If you're going to use this relative to parent option that we checked when we created the document, you're going to want to make sure that when you're done creating your graph, you return it back to 0. Okay? Hit the save button. When we go over to our new graph, which we will rename as master graph, you're going to see our steel is now 1024 by 1024 to match the entire document. So what you're going to have when you open your steel example, you want this width and height to be 0. Essentially what that's going to make the parent, which in our case of the master graph, the parent is this whole master graph here, is the parent of this steel texture which is within the graph. So whatever this parent is set at, it's going to multiply the resolution by what you have set here. And then in the case of 0, you have 1024 by 1024, which matches the rest of your documents. If you were to change your steel example back to 512 by 512, for example, you're going to multiply, it's going to be 2048 by 2048, while the rest is 1024 by 1024. It's something to keep in mind because you can quickly, if you're creating new graphs over here, and then while you're working with them, if you have them set to 2048 by 2048, and you leave them there, and then you drag them into a parent graph, it's going to make your texture resolutions really high, and Substance Designer is going to run really slow. So before you exit your child graph here, you want to make sure that you change the resolution before you go back to your master. Okay? If that doesn't make more sense, you can watch more tutorials, but it's something to keep in mind. Okay, back to the layered materials option here. We have some earth, which is the basic earth color. It's nothing special. There's no bump map to it at all. It's just, it provides the diffuse roughness and metallic maps to create a basic earth texture. Okay. If I want to blend these two textures, what you can do is to go to the material filters down here in your library, and you can go to pull out a material blend node, for example. And what that allows you to do is blend one material with another based on a certain mask. The mask can be anything you like. So we will drag your metal texture in here, and then we'll delete these connections. Drag this option, the earth texture, into the top one. The mask will modulate the material in the topmost slot, which if you zoom in really close, you'll see is material 2. It's a little bit cut off there. And so this little node right here is gray, which means obviously it's a grayscale mask. So all you need is a black and white image. Substance Designer provides many of those. We'll go to your noises option here, and we'll just pick a basic, let's see, black and white, maybe a crackle, Voronoi cells kind of black and white image, and then you can drag that into your mask option, and what you'll see is you have your metal wherever the image is white, you will see your earth, and wherever it's black, you will see your steel masked out, right? That's the purpose of the mask. Wherever it's white, you'll see the material on top, and wherever it's black, it'll be this part will be hidden. Okay? And that does look strange, I know, but you can dynamically change this color information, right? If you wanted to do something that makes a little bit more sense, maybe use a cloud texture here. It looks a little bit more like dirt. You could also, if you have this node selected, then you right-click in your graph, you can change the levels of your node, which means you can bring more white and dark, more white and black values out where you need them. So if you want more dirt, say here, where the levels are the brightest, you can add more white values to the picture by dragging your white high down, and you'll see your earth will show up more in the graph, right? And so you have more or less you have a physically accurate model here where as long as you created your earth material accurately, you have that overlaid with your steel, and you get some pretty nice effects. Okay, so this in a nutshell, very quickly, is part of the power of Substance Designer. You can create a stockpile of base material nodes, and they don't have to be simple by any means. I mean, you can open up some of the default materials that Substance gives you, and you have some pretty sophisticated ones like this brick here. Right, the brick doesn't just have options to change color, but you can change brick depth, size, color, the normal strength, all sorts of things. You can do some pretty bizarre things. So if I plug the bricks into the topmost value here, you have a very odd combination of brick and metal combined, which obviously doesn't look accurate by any means, but you get the point. You can layer anything on top. Okay? And finally, you have the option, instead of using a material mask right here, they have another node in Substance Designer, which we're going to touch on in the next video, which uses a material color blend. No, wrong one. It uses a multi-material blend. There it is. And your multi-material blend will let you choose not just two, but any number of materials, if you select from the drop-down menu here, to input into this graph. And based on the color mask that you have input, you can modulate which materials belong where, right? So we've already created our material ID mask, which is the color mask that we did in Photoshop. In the next video, we're going to discuss how to plug that map in here, and then we're going to connect all the materials that we want in our final, that we're using in our level. And then the output will either directly go into our maps, or we will create other effects between like dirt, grime, to make these pretty shiny materials look a little bit more realistic, because nothing in the real world is perfect, right? So we'll conclude this video, and then in the next one we'll discuss our workflow and how to use the normal maps and the material ID maps we created to create some more sophisticated textures.